Hi, Michael here from the Austrian Institute of Technology. I'm going to show you today a short tutorial on how to use our so-called Drying Toolbox. With this Drying Toolbox, you can analyze your industrial drying processes and see how efficiency measures such as direct heat exchange or heat pumps can increase your energy efficiency of your drying process. Let's take a closer look. So here on the left, you see the input mask with the moist product parameters. Mass flow, you can type in a heating capacity, your inlet temperature and your product temperature at the outlet, your product moisture, and also your final moisture after the drying process. So this is basically the parameters which define your drying process. Then you can put either heat loss into your dryer. You specify your air temperature inlet of the dryer. You can specify the fresh air parameters with a flow rate and with a temperature. So basically what you see here. And this is how the drying process looks. So you have the fresh air here. We have here our 150 degrees desired dryer temperature. And here the product, how it is dried. And in the end, we have here the wet exhaust air, basically, which is unused and goes to the ambient. So when you have set up all your input parameters, to the other parameters we come back later, you can click here at the bottom left, calculate, and there you see your result. So our drying process with our desired product parameters takes up roughly 3 megawatt thermal heat. Yeah? So now, looking at efficiency measures, what we can do at first place, we can add a so-called cooling zone. Yeah? So adding the cooling zone by clicking here, we can type in, let's say, our desired product outlet temperature after that, so 35 degrees. You can also put the heat loss, but I don't do that there. So with the cooling zone, I calculate again. So we went down a couple of kilowatts, so not really that big influence. But what, of course, has a bigger influence is when we add a direct heat exchange. So you can click here on direct heat exchange, and there you see a heat exchanger is added. You can specify your desired temperature after the heat exchange. So here on the wet exhaust air side, so here we're entering with our dryer exhaust temperature of 95 degrees. And we say, okay, our heat exchanger should go down to 50 degrees. And on the other side, it's heating up those roughly 26 degrees to a desired value. Let's click on calculate again. And we see we can heat up our incoming air up to 73 degrees, which in turn means we can reduce the thermal input down to 2.3 megawatt. Yeah? And now adding a heat pump, so the heat pump would decrease the temperature further down after the direct heat exchange and heats up the air right before entering our dryer. So we can specify here the source temperature of the heat pump. We want to cool down the exhaust air down to 29 something degrees, and we will see. We calculate again. Okay. We are below the dew point, so this is our moisture extraction, roughly 0.2 kilogram per second for this specific case. And what we see, okay, our net thermal input for the dryer, which is usually gas, went down to zero. The heat pump has a heating capacity of 2.3 megawatt. With an electric input of 1.1 megawatt, it runs at a COP of 2 because we put in there a Carnot efficiency of 60%, which is a usual value. The heat pump has a temperature lift going from 29 to 150. So those are typical heat pumps which are already available on the market. And this is a simple example how to use our drying toolbox, putting in your numbers of your drying process and increase it further by adding cooling zone, direct heat exchange, or heat pump. You can either play then by adding a recirculation. This would increase your efficiency even further, but this could be done by an extra calculation afterwards. So, thanks for watching. You'll find the link to this Drying Toolbox in the description, and wish you a nice day. Ciao.